I'd like to introduce our third speaker before the panel, and we'll be able to set up the panel here in just a minute, and then we'll have some lunch. Our final speaker before the panel is Trent Brunson. He's a research engineer and security specialist at AIS, headquartered right here in Rome, New York. And he's a PhD candidate as well in computational physics with Emory University. I think Atlanta, is that correct? Yeah. His curiosity and focus in complex systems keeps him out of trouble most evenings, I'm sure. And he's going to be talking about a research initiative that he's working on in SBIR called Localized Encryption Groups, which provides some hope for a more proactive approach. So for some of the data exfiltration problems that we're seeing, and that's a key component of many of the insider threat situations that we find ourselves in. So I'd like to introduce Trent Brunson. Thanks, Trent.
Thank you. Okay, I guess everyone's in, so I want to thank everybody for the opportunity to speak here today. This is quite a privilege. I was really excited when I was asked to speak here because I think insider threat's really a fascinating topic, and I went to Black Hat and DEF CON about a week ago, and I heard a really good talk by a guy named Patrick Reedy from the FBI who was talking about the 5 lessons he learned at his time at the FBI concerning the insider threat. And I wanted to start off today by sort of giving you the 25, you people have the misfortune of hearing the 25-cent version of it. But I want to start off by just summarizing what he went over, and the reason I want to do that is because what we're trying to do with localized encryption groups is along the same lines of what he spoke about, and I think throughout this talk I'll refer to this as LEG, which I'm not a big fan of the title, but that's just what the acronym is. So localized encryption groups are it's a phase 2 SBIR that we're working on. That is focused on encrypting data at the file level. And then, so I'll go over some more of the technical details, but first I want to kind of go over the insider threat. So the first lesson that Reedy talked about was the misunderstood threat. And that was the fact that insider threats aren't necessarily hackers. And this sort of makes a lot of sense because if you think about what Manning did or what Snowden did, they didn't crack passwords, they didn't capture packets and reverse anything. All they did was just go in, copy data, and leave. There was no hacking when it came to that. So I think that a lot of the tools that are built for insider threats are with the mindset that we have to focus on the hacker, but the insider threat isn't necessarily the hacker. He reported that 24% of the FBI incidences and 35% of their time was spent addressing what he called the knucklehead problem, which I guess is what we refer to as the unintentional insider threat. And he wanted to make it very, very clear that the insider threat isn't the knucklehead problem. And I think that it's very important that we make these definitions very clear, because if we make these definitions very clear, we'll know exactly how to address the problem. It's not advanced persistent threat. It's not APT, because APT are outsiders trying to steal credentials to get inside of an organization. And I think one of the speakers earlier today mentioned that the behavior of APT doesn't mimic that of the insider threat. You would have more of a probing type of behavior, looking through the file system, trying to find certain files, whereas an insider threat knows exactly where the files are and wants to exfiltrate them. So he defined the insider threat as being authorized users doing authorized things for malicious purposes. And so I think that that's a very succinct, it's a very direct definition that I sort of took away with it, and it sort of made me think about, it sort of made me rethink about what the insider threat was. So all these different types of threats should be addressed differently. Who is the insider threat? The insider threat are basically people that we trust. People who join organizations. Manning didn't join the military with the intention of exfiltrating data. Snowden didn't join the NSA with the intention of exfiltrating data. Their behavior changed over time. So these were people that we trust, and then that's why behavior analysis is so important. When it comes to an organization, it's important that we identify what our most important information is. That's the role of not only upper management, but also it's important that you talk to the engineers. If you talk to the people who are actually working on the project, they can tell you what exactly is important, what's proprietary, what's the super hard problem, what we should protect. And so you have to ask yourself, who are the enemies going to target within your organization? Who are the high risk people? And I think that it's also been discussed today where we have to look for context. Our people, we have to look at finances, we have to look at people's motivation, a credit card, travel, are they traveling a lot? We have to look at the reports. So we have to identify these threats and just maintain it. And we do that by keeping in contact with HR. They're the people who are the closest to whether or not people are happy or unhappy at work. And I think that this is sort of a theme that I've seen throughout today, is that we see people who are disgruntled or who feel like they've been wronged or they feel like they deserve a little bit more, and so they just want to get back at, retaliate for whatever wrongdoing they're feeling. So the third lesson that he discussed was to focus on deterrence and not detection. So I think this is where LEG sort of focuses. This is where our localized encryption groups, I guess, shines, because what we're doing is trying to deter people from the insider threat, because the idea behind it is that you can't leave data on disk unencrypted. You can't store data or transfer data unencrypted. You have to have a LEG-enabled device in order to see clear text data. And so what this does, it deters people from, or it makes it more difficult for the insider threat to accomplish his or her task. So one of the cool stories that he talked about when it came to the FBI was that they had a pop-up. They installed a pop-up for people. And so when people got on social networking sites and you make a status update on Facebook or something like that, there was a pop-up that came up, and then you could either accept it or reject it. And so they would count the number of accepts and rejects over the course of time to see how people behaved. And what they expected were the number of rejects to ramp up. However, what happened was the number of accepts went down. So what that meant was people changed their behavior at work when it came to doing social networking, when it came to attaching file attachments to emails. They changed their behavior. And what that does is not only does it remind people that they are being monitored at the workplace, but in terms of an insider threat, it's easier to pick out an insider threat when everyone's behaving the same. And so if you can get all of the employees in your organization to behave the same online and have very similar traffic, the insider threat's going to stick out more. The fourth thing that he talked about was the data overload problem. So, and he stated that there are 2.2 petabytes at the network level of information. So it doesn't make any sense to try to pick out the statistical anomalies out of 2.2 petabytes worth of information. That's just too much information to try to try to sift through, and we don't have the tools or the statistical analysis to pick out when somebody, you know, when you talk about 2.2 petabytes worth of data, what is it when somebody exfiltrates 32 gig? That's not that much compared to the grand scheme of things. Finally, his last lesson was to recognize that detection is a hard problem. Detecting the insider threat is a very hard problem. And we should think more like marketers. We need to think more like credit card companies. If I go out and I use my American Express card right now to buy 10 pairs of women's shoes, it's most likely going to get flagged, and they're going to reject the transaction. These people at credit card companies, they have very proactive devices that have learned my transaction behavior, and they know exactly what I buy and what I don't buy. And it's not only to protect their assets, but to protect my identity and my assets as well. So that's just sort of a little summary of what he talked about, and it really resonated with me, and I felt like that what we're trying to do with LEG is sort of in step with that, and that's why I wanted to sort of start off with that. I should actually keep an eye on the time. Okay. So the problem that we have is that we continually want to share information. We want to, within organizations, especially in the government, we want to be able to communicate with each other. And with this, we have this problem of trying to detect all data transactions within networks. That means there's multiple file types, multiple network protocols, multiple data sharing technologies. So the current technologies that are out there that do encryption, you'll notice there's sort of a common denominator in all three of them. First, there's the file locker, and then there's the DoD encryption wizard and the file vault. All of these were designed to keep outsiders from accessing your data. They don't necessarily prevent insiders from exfiltrating data. And so we wanted to create an encryption device that would help specifically for the insider threat. And so the way LEG works is this. We create an automatic encryption service that never leaves the data at rest or in transit and in clear text. So what happens, if you start from the top of this diagram and work down, whenever you create a document and you save it, the LEG is a Windows driver that intercepts the reads and writes and then wraps it with encryption and then stores it to disk. And this also occurs whenever data is being transferred as well. And so the way we're doing that is we've written a file system filter that will actually go into the Windows file system and intercept these things. It's not an easy thing, and what we've done is deploy there's a company called OSR, and they have a data modification kit, and so they have a source code with that, and so with that you can easily manipulate the Windows file system. And the reason we chose Windows file system is because it's the most popular enterprise operating system that a lot of companies use. So the idea is that we never leave data on disk unencrypted or in transit unencrypted. This works on a per file basis, so each file is treated differently. What we try to do also is work with LDAP servers and just regular Windows Authority to dictate the role-based access control credentials, and then that will enforce whether or not people can encrypt or decrypt files. Finally, yeah, so the last part's really important because we wanted to develop a technology that wouldn't interfere with people's workflow. I think that what discourages people a lot when it comes to encrypting or protecting your information is how is it going to interfere with my day-to-day activity. I don't want to think about encrypting my data. I just want it to do it and then me not have to worry about it. So that's why it was important that we built a Windows driver to do it, because it sort of sits in the middle of the system and it does all the encrypting without the user ever knowing. So when you open up a Word file and you click Save, it does it, it encrypts it, you don't have to worry about it. So the way it works is that there's a whitelisted applications. So, for instance, if I were to open up a file with WordPad, and I'm not allowed to access it with Notepad, I guess they're two different applications. We can regulate these policies. All the user land uses the Windows crypto API to handle all the encryption as well. So one of the things we wanted to make sure is that we're building a FIPS compliant software, and so what we did was access the Windows API and to do all the key handling and all the transactions. So the way it really works is here it is. Okay, so if you look at the file content, this would just be like a regular Notepad or a PowerPoint or whatever it is. So what happens is whenever you click Save, it'll wrap everything in headers. And so the first part of the header will tell the system that it's a leg file. And then what we have are users' public keys and their private keys. And so, or their encrypted symmetric keys. So the Windows crypto API is it's the one that's sort of handling everything on the server side. And what this does is not only restrict certain users and certain organizations and certain applications, but it also allows a certain provenance to be, or a record to be kept as the file's being touched. So each time you click Save, each time you open a file, that's all going to be stored in the headers. So one of the technological challenges that we're facing is, how can we keep this manageable with 1,000 employees, with 10,000 employees? How can we keep up with that? And so that's one of the challenges that we're facing right now with this SBIR, and that's what we plan on working on for the next 18 months or so. Another thing that we're using is our common access cards. We want to be able to have it to where you can just plug in your CAC and then decrypt all your data, but if it's not plugged in, everything is encrypted. So we're working with that technology as well. We have a pretty talented co-op who's working on interfacing the CAC, the smart card reader, with the Windows API, and he's really talented. And also, what we're looking for is to be able to restrict copy and pasting. So we're really trying to tie up all the loose ends, and I think that's one of the things that I'm hoping to get out of today's discussions is if you can think of something where, have you thought of this, or have you thought of this scenario? We're really trying to come up and enumerate all the possible scenarios where someone might be able to exfiltrate data. So we don't want people copying a massive amount of data to the clipboard and then opening up Outlook and then pasting it to an email and then sending it to themselves or to somebody else. So we want to access we want to control all the data flow that we can. And so I think that's pretty much my last slide. These had to be approved, so this is a former briefing, and I don't have a demo, obviously. So, I'm with AIS, and I would be willing to have anybody come over and we could show you a demo of what we have so far. It really is seamless. It is one of these things where you just click Save, and it does all the encryption. And right now, we just have a rotation cipher built in. but we're trying to work and put all the parts into place. You know, we have basically the file system, the driver, and then we have all the common access card stuff, and then we have the Windows crypto API stuff, and then right now we're trying to get them all to talk together. And so that's what we're going to be working on for the next 18 months. And so what we want to do is, you know, keep up with the provenance and really deter people from the insider threat. We really want to deter people or discourage them from wanting to exfiltrate data. They know that whenever they copy something to a CD or a USB, it's going to be encrypted, and it can't be encrypted unless they're on a machine with leg and with their validated credentials. So I don't know how much time I have, but I'd be more than happy to open up. Yep.
What kind of performance hit do you take, and does it grow linearly or otherwise with either the number of file or the number of header entries you have to write?
Okay, so the question was, what's the performance hit that we suffer? Right now, the headers that we find increase the file by about 64K. What we want to do is take the DMK or the data modification kit that we're using to implement all this stuff and just pull out specific functions. Right now, we have the whole thing built in, and it takes about, to boot up or to load the driver, takes about 30 seconds to a minute. But once the driver's loaded, it's fairly fast. It's pretty seamless.
Okay, let me delay one thing. We're going to go ahead and have a couple of folks organize tables and go ahead and ask a couple of questions here while we get the panel set up.
Sure.
So I have one comment and one question.
Okay.
So the comment is what you said about the amount of data, right? You said megabytes or whatever.
Yeah.
And I agree with you. There's a lot of data, but you have to be smart about how you look into this data. You can't look obviously everything. It's not possible. But you can filter out things which you are interested in, and then the statistical methods, machine learning, other things apply and can be used.
Okay. Let me just comment on your comment. So his comment was, you have to be really smart about the way you handle the data and the way you parse it out, and with that, you can sort of overcome some of the obstacles with the big data problem. One of the things that Reedy mentioned was that he recommended individual audits to try to sort of focus in on human behavior and focus on specific behavior, what's going on with individual logs. That way you're not looking at the entire network. I think that people also all assume that everything fits to a Gaussian curve, and then yeah. So so that it's a really big challenge, and you know, I come from a statistical physics background, so I know what it's like to, you know, try to pick out the certain anomalies or the certain moments in the distribution, huh? Yeah, exactly.
The question which I have is related to your approach, which you described. It's you add software to the system, right? You add stuff to be able to achieve the objective which you described here. So now the question is, how do you deploy this in a secure way so that whatever you do does not create new potential entry points for the attackers? Right, so that somebody can use your software now and try to get into the system. Are you looking into this issue, or you think everything is okay?
Oh yeah, I mean we're trying to look into every issue possible. You know, we want this to be a commercialized product by the end of the SBIR, or at least very close to it. So that's, from an insider threat point of view, that's, I don't know, to me, that's not really an insider threat. That's an outsider trying to get in and trying to gain access. I think to do that, the way we have it designed right now would be to inject your credentials onto a Windows 2008 server, because that's where all the private keys and public keys are handled. And so that's really the only way you would be able to gain access. What we're doing is not it's not necessarily it is a software, but it's a driver. So it's a driver that's installed. So the idea is that you can give this to IT, and then they can install it on all the boxes on the network, and then it just works. And so that's sort of our vision of what we want it to happen. And you know, we're doing everything that we can. We got a lot of smart people working on it that are really excited about it.
Okay, thanks. Okay, I'd like to ask the panelists if you want to wander up. I think we've got 4 or 5 folks that are set to come up. And thank you very much, Trent. Appreciate it very much.